if you recall from last time, we did a moving average model and we looked at the condition for invertibility. So this side, the root has to lie outside the unit circle. If it doesn't, then we cannot invert it. The last example that we did, it was invertible, and we had the expression what's the next one? 0.29
plus 292 z squared minus 0.158 z cubed.
and dot dot dot.
Is that 0.54?
Yeah.
Right? So even though we started with a moving average model, we kind of took an ad hoc approach and converted it to we're about to convert it to an autoregressive model. What do I mean by that? If you distribute the yt, we'll have yt minus 0.54. I'm going to change z to a lag operator L. So L multiplied by yt, 0.292, L squared multiplied by yt, minus 0.158, L cubed multiplied by yt, dot 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 equals epsilon z. Correct? And I can move everything except yt on this side. So yt would equal 0.54 L times yt is simply 0.54 yt minus 1. 0.292 L squared yt is minus 0.292 y sub t minus 2. 0.158 L cubed yt, it is yt minus 3. Move to the other side, we will have 0.158 yt minus 3. Plus dot dot dot, and then epsilon t. But we can truncate the model as necessary. So what we did is we took an MA1 model, which is a moving average model, and converted it to an autoregressive model, which is an AR model. So what do we mean by autoregressive? If you look at yt depends on itself with lag 1. So linear regression, y is regressed on x, and we say y is the dependent variable, and y depends on x. Here the time point t depends on itself at time points t minus 1, t minus 2, t minus 3, so we call it an autoregressive model. Now, why should I do it this way? Because finding the coefficients of an MA model is difficult directly. It requires computation. But if we convert it to an autoregressive model, then I can estimate the parameters for the autoregressive model and use that to come up with the parameters for a moving average. Does that make sense? Okay, so now we'll talk about AR1, AR2, AR3. Once that is done, we can do forecasting using a real series. It should make sense today as to why we spend time with first difference equations, second difference equations, third difference equations. A first order autoregressive model is simply YT. Is equal to phi 1 yt minus 1 plus epsilon mod epsilon t. This is something we have seen before. And epsilon t is normally distributed with some mean mu and varying sigma squared. Typically, if we subtract the mean, it will simply be 0 and sigma squared. What did we do after we found the expression? What was the next step of moving average? We found something immediately after doing, writing the model.
Characteristic equation.
Yes. I'll give you a hint. It has something to do with the boat. Covariance. Rho. Get it?
Oh,
Rho covariance. So we found the covariance. So we'll start with gamma naught.
wait, and why isn't it not 0, sigma squared?
We can have it 0. This is the general case. Remember, I mentioned if we have a mean mu, then that'll be the mean. But if you subtract it out, then it will be 0 sigma squared. So we can have it as 0. The important condition is that it should always be normal. So we want to define covariance of yt, yt. We'll start with p plus h. This way we could simply plug in the value of h and be content. Good. So we look at time indices that match when we plug in the values of h. So I'm going to start with h is equal to 0. So gamma 0 would be covariance phi 1 yt minus 1 plus epsilon t. Phi 1 yt minus 1 plus epsilon t. Those too much. Yes. So these are the terms. I'm pulling out phi 1, pulling out phi 1, so I will have phi 1 squared. And plus epsilon t, it's simply covariance. Good. Yt minus 1 will have the same variance as yt, correct, it's the same series. So we are going to end up having phi1 squared gamma naught. Right. The reason being, gamma naught is covariance of yt comma yt. If you replace t by t minus 1, we're still talking about gamma naught because covariance of yt minus 1 comma yt minus 1 still gamma naught. And this one is sigma squared.
So that means sigma squared would have to basically be 0 and
Now I'm just going to say, could that sigma squared ever be 0? Sigma squared is variance. And
It can't be zero.
it can't be 0. Because if sigma squared is 0, then you're saying everything is constant, no variation at all. Then what is the point of time series, right? So sigma squared cannot be 0. In general, variance cannot be 0. So I can move that phi1 squared to the underside. And I will have sigma squared so gamma naught would simply be equal to sigma squared divided by 1 minus phi1 squared. Good. What is the next step? Finding the roots. We could deal with the roots later. We've been dealing with the roots for a while, but we will talk about them later because we haven't talked about the complex case. We need to find something else. With MA1 model, MA2 model, we found gamma naught. After finding gamma naught, what did we find? So, where's that slight mistake? So, in general, erase the part that we had previously. We know gamma H is covariance of yt, comma, yt plus h. Yes. So I want to find gamma 1. So this would equal to covariance of phi1 yt minus 1 plus epsilon t, comma yt plus 1. Yes?
wait, hold on. Why is phi1 just the covariance of yt minus 1 plus epsilon t and yt plus 1?
I'm going to get into that in a second. Because of, regressing or correlating with the past by one value or in the future by one value. So, or one time point. So we have yt minus 1, there is yt plus 1. I'm not rewriting it, I'm rather keeping it as is. There is no correlation between epsilon t and yt plus 1 directly. So what I can do is put that term to be 0. So covariance of phi1 yt minus 1, comma yt plus 1 plus covariance of yt minus 1, comma, epsilon t. All I'm doing is splitting the two terms apart. So yt minus 1, yt plus 1. When I go to gamma 2, it would make sense as to why I'm doing it this way. So noise and y, they have no correlation, that would become 0. If I pull phi1 out, gamma 1 would be phi1 multiplied by covariance of phi1, or sorry, yt minus 1, comma, yt plus 1. And since it is the same series, there has to be covariance between the y's. So this would become y1 or phi1 gamma naught. Good. So if I go to gamma 2, gamma 2 is covariance of yt, comma, yt plus 2, which is covariance of phi1, yt minus 1 plus epsilon t, comma, yt plus 2. Correct. So, same argument, epsilon t, yt plus 2, it would be 0 because it's noise and the series. We'll have covariance phi1, yt minus 1, comma, yt plus 2. I mentioned a long time ago that covariance is symmetric in the sense gamma of 2 is the same as gamma of minus 2. So going 2 steps forward is the same as going 2 steps backward in terms of correlation. So using that property, since gamma of h is equal to gamma of negative h, I'm going to replace gamma 2 or rewrite it as gamma negative 2. Just for the sake of understanding, I could have done it over here, but it will become clearer in this step. So covariance of phi1 yt minus 1, comma, yt minus 2. Do we agree? If gamma 2 is equal to gamma negative 2, I'm simply changing the positive 2 to the negative 2, correct?
And now it's only one step away again.
So phi1 can come up, you'll have 1t minus 1, comma, yt minus 1 minus 1. Yes? If you can't say it directly, I can call S is equal to t minus 1. Then I would have phi1, covariance of ys, comma, ys minus 1. Correct? I'm just making a substitution so that you can understand it better. Well, what is the covariance between time step s and time step s minus 1? It is just gamma negative 1. Do we agree? But gamma negative 1 is the same as gamma positive 1.
So unlike the MA models, this will have like two extra, no, not extra, like one, like it'll have more solutions because the gamma 1 equals gamma -1.
What do you mean by more solutions?
Like
Do you mean to us that we don't have more covariances when it comes to an MA1 model?
yeah, like you can go further with the H's even when you're only using.
You cannot with an MA model, moving average model, because there we're representing the time series in terms of noise, right? And if I said that the time series is a linear combination of noise today and noise one step backward, none of the previous noises would matter, correct? But that is not the case with an autoregressive model. If I said yt depends on yt minus 1, then intuitively yt minus 1 depends on yt minus 2. Do we agree? Yes, you with me? Yt depends on y2 minus 1. Naturally, yt minus 1 must depend on yt minus 2. And yt minus 2 must depend on yt minus 3. If that is the case, then if you go back, we started at yt, indirectly depends on yt minus 3. Yes? So gamma 1, gamma 2, gamma 3, they will all exist. But would you expect the gammas to happen as you go farther and farther and farther away? It'll get smaller and smaller and smaller. So eventually it will become 0, but it would not become 0 at the very first step, or for h greater than or equal to 1, like it did with a moving average point. Yes.
So is the pattern going to continue like gamma 3 would just be
I'm not going to give you the answer. So phi 1, gamma 1. So we know gamma 1 is phi 1 gamma naught. So this would simply be equal to phi 1 multiplied by phi 1 gamma naught. We get phi 1 squared gamma naught. Good. I'll give you a few minutes. Let's find gamma 3, and eventually we'll get an idea as to what gamma h would look like. So, same approach, gamma 3 would be equal to covariance of yt plus yt plus 3. But we know gamma 3 is equal to gamma -3, so we'll make that change in a bit. But covariance of yt minus 1, phi 1 yt minus 1 plus epsilon t, comma yt plus 3. We are rewriting it in terms of -3 so that we can understand the algebra better. So this would equal to covariance of phi 1 yt minus 1 plus epsilon t, comma yt minus 3, because gamma 3 is equal to gamma minus 3.
out of curiosity, could we also instead change it to phi 1 yt plus 1?
What did you say?
Out of curiosity, could we also instead change the phi 1 of yt minus 1 to phi 1 yt plus 1?
Yeah, you can, but that wouldn't help us go any further.
Yeah, okay, I'm just curious.
So gamma 3 I can pull the phi one out, covariance of yt minus 1, and epsilon t and yt minus 3, they're not connected, nor is in a series, so common. The term that is left is yt minus 3. I could write it as t minus 1 minus 2. Yes? And if I said s is equal to t minus 1, just to see things better, so covariance of yt minus 1, comma, which is s, comma, ys minus 2. Correct? Yt or ys, comma, ys minus 2, the covariance is simply gamma 2. Correct? Or gamma minus 2. But gamma minus 2 is actually gamma 2. But we know gamma 2 is phi1 squared gamma naught. Or
Would it be gamma cubed?
phi1 squared gamma naught and phi1. You plug that in. Now you would have phi1 cubed gamma naught. So gamma 1 happens to be phi1 gamma naught. Gamma 2 phi1 squared gamma naught. Gamma 3 phi1 cubed gamma naught. What is gamma 4?
V1 to the fourth.
Gamma naught. So in general, it's phi1 raised h gamma naught, correct? But we know this also equals to negative h. Correct. So, but we can't put phi1 raised negative h. That doesn't make any sense. So it still has to be phi1 raised h gamma naught. Reason being, these two must be the same. If that is the case, these two should remain the same. So what is a compact way of writing for both positive and negative values of h? Absolute value, very good. So that is the autocovariance function for an AR1 process. We have gamma naught, we have gamma h in general, so we can find the autocorrelation function.
Professor,
Yes.
would it, is it h greater than or equal to 1 or h for the absolute value of h is greater than or equal to 1?
What?
For the h greater than or equal to 1, is it like that or should it be the absolute value of h is greater than or equal to 1?
So autocorrelation function is simply each gamma h divided by gamma naught. So we have to divide this by gamma naught, and we can do it directly. If we divide by gamma naught on both sides, left hand side would be gamma h over gamma naught, which is rho h. Correct. And the right hand side would simply become,
Sorry, can you repeat that?
if I divide by gamma naught on both sides, which is what we do, we take gamma h divided by gamma naught to get rho h. So if I divide by gamma naught on both sides, I'll simply get rho h equals phi1 raised to the absolute value of h. What is the value of rho h when h is equal to 0? One, always. And note, gamma naught is sigma squared divided by 1 minus phi1 squared.
So even with the AR models, what is that P thing called again? Row one is when H is 0 is always 1 regardless if it's an AR or an MA.
Yes,
Okay.
because you're correlating the series to the top. We don't forget the gamma naught. 1.
Like, in
Yeah.
the product, yeah.
No, to get rho h, we have to divide by gamma naught.
Oh, so it cancels out.
Yeah, it'll cancel out. Right, that's how we did. When we found rho 1, we took gamma 1 and divided by the variance. And variance is simply gamma naught. So it'll just cancel out. So does that make sense? So let's start with an AR1 model. Y is equal to 0.25 yt minus 1 plus epsilon t. Now, I want you to find rho h for 0, 1, 2, 3, 4, 5. And tell me what rho h is for each of those values. So the value of rho h when it is 0, 1, always. And here,
0.25. 0.0625. 0.0156.
0.56.
Okay. 0.0039. 0.0009. 8, I guess.
So what pattern do you notice? Yeah.
Is each of them a quarter of what it is before?
What?
0.0625 is a quarter of 0.5, 0.0156 is a quarter of 0.0625, vice versa.
No, it is a quarter of the previous
That's what I-
case.
that's what I
It's
was saying.
because that's a quarter.
Okay.
If this happened to be 1/8, the pattern would be in terms of 1/8. So the quarter from here goes in. Okay, does this make sense? If it kept on going all the way up to 10, what do you think would happen?
Much smaller.
It's going to get smaller and smaller. So, based on these values, what can we conclude?
It's aggressive.
How strongly is yt connected to yt minus 2? So whatever that's happening today, related to 2 days in the past.
Like that day where the batteries flash as a day's student.
Right, it wasn't as good as yesterday, right? How about 5 days into the past? So does today depend on whatever that happened 5 days ago?
Not very much unless you were.
Not very much, by a very, very tiny amount. So if this pattern continues, today, whatever that's happening today, it's not related to Y10 at the 10th day in the past period,
Unless you're
because it'll be 0.
That's unless you're right at Chroma, then you, I don't know, can people actually hear,
Then you wouldn't have a model at all.
I mean, when you wake up, would you start from the past day you were aware of, or would you just start from the day before?
I don't know, I've never been in one.
Either or not, that's what I'm curious.
So
Science.
this is true because YT is slightly dependent on YT minus 1, the previous day. So the progression that you would depend will be really fast, and by the 5th day, there is no effect from, day 5 or day 10.
I'm guessing that.
But if this value was, say, 0.9, you would have a stronger connection, but eventually it would dissipate, yes.
So that means P1 must always be less than 1, otherwise it wouldn't be
That is
progressive.
correct. Now, phi1 to be less than 1 is something that we had seen before. Well, long time ago.
Use like an exponential. You see?
Exponentially. Remember, we did first difference equation, and we did, when we found the roots of phi1, we said that has to lie outside the unit circle, bigger than 1. If it doesn't, these values wouldn't be going down, right? So if phi1 was 2, this would be 2, 4, 6, 8, 10, 16, and it's going to keep on going. So what we are saying is, well, whatever that is happening today is 1,000-fold dependent on the 10th day, 10 days ago. Doesn't make any sense. This is an AR1 model, so it has to just depend strongly on the previous one, not on the 10th day. So geometric series, remember we said it has to be less than 1, the absolute value. That's what we're talking about. So phi1 has to be between -1 and +1. I want to show you ACF for the 2 cases. So let me quickly show you that with this point. Yeah. So I've created 3 different series. All of them are autoregressive. The first one has a phi1 value of 0.8. The second, 0.3. The third, -0.25. They're all of length 256. So that is the autocorrelation function for pointing, right? So you can see, if you count the peaks, 0, 1, 2, 3, 4, 5, 6, 7, right at 8, it starts going below the line of significance. So it is an AR1 model, but it's decreasing at step 8, and it becomes insignificant, and past 8, it's just gone.
Sort of freaked out about
We shouldn't be looking at 20. We'll stop right here.
Yeah.
Right, because that that dotted line indicates if you have a significant correlation or not. So if you go for the next case, what do we expect? Do we expect the decay to be sooner or later? Sooner. It has to be sooner. Happen right away because it is a small P1 value. If I'm correlated to the previous day by a tiny amount, it is highly unlikely that I'll be strongly correlated, 10 days ago. Lastly, we have said, notice that V1 in this case is negative 0.25. So we will still have a decaying trend, but it will sort of alternate. You see it's going back and forth. It's not very clear. So let me just increase up to 0.95. Right? So it is decaying, but it's going back and forth. So today depends on yesterday in a negative manner, right? Because V1 is negative. But yesterday's negativity came because of positivity. The day before yesterday's positivity happened because of negativity.
All we have issues.
So, yes. So it goes back and forth. Does it make sense? So